Okay, this video is going to be about variable geometry turbochargers. I was working on a gas engine this weekend, sorry. So, variable geometry turbochargers were designed to meet several of the obstacles we had. We talked before about how that initially turbos had to be sized for like high RPM and high load, so you had a lot of turbo lag at low RPMs, black smoke we had to get rid of. So then we came out with the wastegated. That got us by for a while, but some more issues came up with emissions and everything. We needed to tailor a turbo boost pressure for every situation the engine was put in. So that's where the variable geometry come out, and we'll get into some other reasons for it as well. So about the variable geometry, I know this video quality is a little poor. It's hard to do this one person, but basically inside here you have what's called a unison ring, and the unison ring is connected to these little vanes here, and it's a unison ring because they all move together. So what this allows us to do is basically change the area of the turbo inlet here, like we talked about with the AR ratio. So the radius is going to stay pretty much the same, but the area is going to be able to change to tailor to whatever we need at the time. So if we don't need very much boost at all at an idle, it's going to open up these vanes and allow the exhaust to move through more freely. If you think about, if you blow all your air through a straw, then it comes out with a lot of velocity. There's not a lot of volume, but it produces a lot of velocity. If you moved up to like a 2-inch pipe and blew air through it, you would have an unrestricted volume, but you wouldn't have very much velocity coming out of your lungs. So the variable venturi allows us to change that. Variable geometry allows us to change that and tailor it for what we need. So variable geometry turbochargers are a smart device, and by smart device that means that it's controlled by the computer, and it also gives feedback to the computer to tell exactly where it's at, what's going on with it. So the computer gives it commands, but then the device, the VGT, sends a signal back to say exactly what's going on, what position it's in, where the vanes are at, and it's controlled with what's called pulse width modulation. So pulse width modulation is an amount of time that a voltage is turned on before it's turned off, and the computer's programmed to know that if voltage is applied for this many milliseconds, I'm going to get this much travel out of the VGT actuator, and then the VGT actuator is giving feedback to say, yes, I actually went this far. So that's what makes it a smart device. It's programmable through the scan tool, and DCM's programmed as to what it wants the VGT to do as far as what its limits are and whatnot. So the actuator you can't see off of this cutaway, but I can manipulate it by hand. You can see that as I move the linkage, those vanes move with the unison ring in unison, and they all move together. So wherever this is positioned at is going to control how much air hits the turbine. And remember, the unison ring does not spin, but the turbo itself does. So I'm just changing the amount of area that the exhaust has to go through to get to the turbine wheel. And the smaller that area is, the higher the velocity, but then it also becomes a restriction. So at higher RPMs, this unison ring can open these up a little and not become a restriction to give us a drivability problem. Another thing the VGT allows us to do is to use exhaust gas recirculation. Now we kind of had to skip over that chapter, but remember that we're putting exhaust gas back into the intake manifold through the EGR cooler to lower NOx emissions. If you take oxygen away from a fire, you're not going to have as hot a fire. When cylinder temperatures come down, NOx levels come down. So that's the whole purpose for EGR. You're putting exhaust gas back into the cylinder, but its goal is to take away oxygen. You can't build as hot a fire, therefore cylinder temperatures come down and NOx levels come down because you don't oxidize as much nitrogen. The problem we had with our diesel engines with EGR is automotive's been using EGR since the 70s, but their intake runs under a vacuum. So if they open a little valve to the exhaust manifold, it's just going to pull exhaust in with the vacuum on the intake manifold and flow really easily. Diesel, we had a problem with that because we have a turbocharged intake manifold. So remember, we've got a pressurized intake manifold with boost pressure from the turbo. So if your boost pressure is higher than your exhaust pressure, you're going to push air into the exhaust, not exhaust into the intake, if that makes sense. So a couple of ways we have that happen. We had a Venturi type effect with our EGR valve that's up here on the intake manifold, which is controlled by the computer. So as air goes through the intake and you open the exhaust, the air blowing through the intake kind of pulls exhaust in and helps get that into the intake manifold, kind of like a carburetor. We've talked about how that works with the Venturi, or like a old school paint gun, where the air blew through the gun and pulled paint out of a bowl on the bottom of it to shoot the paint. Kind of the same theory, but it didn't work well enough to get the amount of flow that we want. So what we had to do is put a variable geometry turbo so that we can create back pressure here when we want EGR to flow at a higher rate. So the computer will restrict this enough to force the exhaust in the manifold to go through our tube and cooler and all this back to the EGR valve versus going out the exhaust. So it doesn't become a restriction that robs us of power. It just kind of restricts the area to get out here. So it's kind of like if I've got a bunch of cows in a pen and the gate suddenly becomes smaller, it's going to get really crazy unless I open another gate somewhere and let some of the cows go out that way. So that's kind of what you're doing. I know it's kind of a weird analogy, but I was raised on the farm, so it kind of makes sense. But that lets your exhaust go out this other opening or gate, which is your EGR control valve, into the intake manifold. So we have to use a VGT. We don't have to, but that's the most common thing to use on an EGR engine. So we can create back pressure, or not back pressure, but a restriction in the turbo and make it flow into the intake manifold through the EGR valve.